This is a follow-up video to my video regarding 5.8 GHz biquad antennas. I'm going to look a little deeper into tools, materials, and construction techniques. I'll put my recommended search parameters in the description as to how to look for all these component parts. You're going to need to put these things together. This is the little bulkhead connector that I chose to use. I really like this design because you only have to cut 3 separate holes and it'll work on a curved surface. The center conductor is offset just enough to give me that 5mm backspacing between the solder point and the actual reflector itself. For me, this design was ideal in keeping the reflector from rotating with respect to the actual antenna itself. This little U-shaped reflector was the one and only one where I did full design on the reflector as directly off of a calculator and used all the dimensions recommended. As you can see, it's made from very thin aluminum, probably about 40 gauge, about equivalent to a Coke can in thickness. The U-shape makes it pretty rigid, so it's not near as flexible as the next design, of course, which uses a curved reflector made out of a Coke can. Now, do I recommend using a Coke can as a reflector? No way. Way too thin. Actually change the shape, you can walk by it and the breeze will make it flutter. In this case, it was just a quick and easy design trial and error exercise just to see if it would make any real difference. This next design uses a thicker aluminum, probably around 28 to 30 gauge. The width is the same as before, but I arbitrarily just chose to cut it 4 inches wide and then bend it into a shape of a flat parabola. The next 2 reflectors I made were cut 4 inches by 10 inches and 6 inches by 10 inches. Why 10 inches? It was the width of the material that I had. I tried both semicircle and parabolic shapes. By far, the parabolic shape was best. In this case, a broad, flat parabola gave the best receiving quality. Again, you want to keep your material thin. The reason for this being, of course, it's much easier to form. I found out I could best form this material by putting a broom handle in a vise and then use the broom handle as a mandrel to form the aluminum over. Here is the mounting arm arrangement for all of my antennas. In this case, it consists of a piece of cut PVC, Loc Line straight fittings, an 832 screw about 1 inch long, and a 1024 screw at about 1 inch long, and what was the motor magnet for a VCR. Here's a short straight piece of Loc Line. It has a male and a female 1/8 inch NPT adapter. Here's a little quick demonstration of the tool that you can buy for assembling and disassembling Loc Line fittings. Trust me, if you're going to be doing any work at all with Loc Line, you're going to definitely want to buy this tool. I covered the Loc Line fittings pretty extensively in another video on soldering aids. You might want to watch that one if you're more curious about this material. It was originally designed as a cooling hose conveyance for industrial machinery to throw water on cutting apparatus and keep the apparatus cool. It holds its shape extremely well. There are a multitude of other types of fittings available, some 90 degrees, Ys, and varying nozzle sizes. It also comes in 1/2 inch and 3/4 inch sizes. In this case, it is 1/4 inch size. Here's a complete breakdown of all the parts used in the mounting assembly. Then a little small 1/4 inch thick spacer was just used to keep me from cutting the screw. Just made life a little easier. The PVC I used is a 1/4 inch by 1.5 inches. It's originally designed to replace rotted wood trim on houses, and again, in this case, available from Lowe's or Home Depot. Next on the agenda is a 20-inch SMA cable, followed by this male to female elbow. As far as the solder, I'm particularly fond of the 6337 tin lead solder in about 1mm diameter. Now onto the wire I used. In this case, it was 22 gauge coated, usually referred to as magnet wire. Obviously, you're only going to need a couple of feet of it. In my case, I got mine out of an old pre-high definition TV set that was obsolete. Now we're going to start getting into tools. In this case, this is my own little bending jig. The blocks themselves are 12mm on the side. Obviously, 3 of them gang together end to end. And this makes it very easy to wrap the wire around the blocks and get a very specific shape out of the wire that approximately would be on center line about 12.8 millimeters, center line to center line. I've had real good accuracy and results this on the bending jig. It makes things go a whole lot faster, gives you a nice square arrangement. Obviously, you just take it off and mirror it over to do the other side. Since you're working with very thin copper wire, this seems to be the best way I found to make an accurate bend to come up with a pretty much square block antenna without having any problems. The hardest problem is taking the wire off of the blocks and then mirroring it over to bend the other side. Obviously, I could go back and make 3 more blocks and make as much as a triple double biquad with ease. As you can see here, once you get it off the blocks, the next step, of course, is to find the solder points and strip the coating off the solder points. You can solder it back to the little bulkhead connector. In my case, I like to solder the bulkhead connector on the plus side of the reflector. I tried it behind the reflector on several occasions. That didn't seem to work near as well. Once it's off the blocks, you've got a little minor bending to do to make sure it conforms to the shape you want. Then it's got to be held in place using the tools you'll see shortly, so I can solder it back to the little bulkhead connector. Here are several shots of a finished double biquad antenna element soldered completely in place. The biggest problem in making this is obviously being able to hold the wire and the little bulkhead connector in the proper positions so the soldering can take place without deforming the element itself. That's where Loc Line enters the picture again, as you'll see in the following tool shot. I made several little adapters that hold the wire and hold the connector in place to make it easy to solder and get an accurate connection to make sure it's not deformed with respect to where you want it to be. What you see in front of you consists of 2 magnetic pads as well as an old speaker magnet that acts as a base. All the others are just adaptive heads that can be screwed into the NPT fittings and change the function relative to holding things for soldering. I've had real good luck with the Loc Line creations. If you're interested more, I did a video some time ago on how to use them and my original designs behind them. Here's some more of the tools I used. Of course, a well-stocked Dremel tool, so you can do the drilling, tapping, and cutting on the PVC. A face shield I found essential. A full face shield like this allows the solder fumes to be directed around you rather than blowing straight back up in your face. A miter box for cutting the PVC and making sure that it's square. Miscellaneous pliers. A good soldering station. A square. And a good pair of wire strippers. All came in very handy on this project. Well, that wraps this one up. If you like what you're seeing, consider subscribing. Just might have a few other things coming down you're going to want to see. So thank you very much, and come on back now here. I want to see y'all soon. Take care now.